In this session, we'll discuss about spherical coordinate system. So this coordinate system is very useful when the problem has spherical symmetry. In a spherical coordinate system, a point P is given by, the position vector of point P is given by three coordinates, which are r, theta and phi. So this is the point P. Let me indicate x and y. So this is x, this is y and z in a rectangular coordinate system. Now we'll see what is this r, theta and phi. So here r is the length of the vector from origin to point P. So this is r. And theta is the angle made by this position vector of point P with the positive z-axis. And phi in spherical coordinate system is same as the phi in cylindrical coordinate system. That is, it is the azimuthal angle. Suppose you project this line onto the xy plane, the angle made by this line with respect to the positive x-axis is phi. So the range of r is from 0 to infinity. When point P is at the origin, r is 0, and as it moves away from the origin, r increases. And this theta, it can take values from 0. That is, when it is when the point P is on the positive z-axis, it will be 0, and it can vary up to pi. So suppose when the point P is let's say on xy plane, anywhere here in xy plane, then this theta will be 90 degree, that is pi by 2, and when it is on negative z-axis, theta is pi. And phi, the azimuthal angle, as we have seen earlier, it can vary from 0 to 2 pi. Now let us see how to convert from rectangular to spherical coordinates, that is from xyz to r, theta, phi. So here we can see that this is square root of x square plus y square, because this is a right angle triangle. So this is root of x square plus y square, and so this is same as this side, and this is z. So therefore the value of r is, again, it's a right angle triangle here with sides z and root of x square plus y square. So therefore r is given by root x square plus y square plus z square. And theta, you can see that this theta here is given by tan inverse of square plus y square divided by z. And phi is given by tan inverse of y by x, because this is y, this is x. Now let us see how to convert from spherical to rectangular coordinates. It is from r theta phi to xyz. So here we can see that this side is, because this is r, this angle is theta, this side is r sin theta. So therefore this side is r sin theta. So here x is given by r sin theta, because this is the hypotenuse and this is the adjacent side, this is the opposite side. So x is given by r sin theta cos phi, and y is given by r sin theta sin phi, and z is given by, so if we consider this triangle, this is z, this is r, and this angle is theta. So therefore z is given by r cos theta. So the unit vectors in spherical coordinate systems are given by, this is AR. So AR is pointing in the direction in which R increases, and this is A theta. So when theta increases, there is a direction in which it increases. It is tangential to a circle of radius r. So the radius of the circle is r, and here is the direction of a phi. This is tangential to a circle of radius r sin theta. So we have a circle of radius r sin theta, which is parallel to xy plane, and a phi is tangential to this circle at this point. Now let us try to obtain differential length, differential volume, and differential surface in spherical coordinate system. So let us consider the point A, which is given by r, theta, and phi, and this point P is obtained by incrementing r by dr, theta by d theta, and phi by d phi. So this is r. So let's say r is incremented by dr. We will obtain this point, and so this angle is theta. Let's say we increment theta by d theta. So this is d theta. It's incremented by an amount of d theta, and then this is incremented by d phi, and this is the point B. We can see that we will obtain a differential volume element is something like this, and this side is dr, and this side is given by, because this side is r sin theta, this is r sin theta, so this is r sin theta d phi, and this is here, this side is obtained by incrementing r by this theta by d theta. So therefore this is going to be r d theta. So The volume element has sides dr, r d theta and r sin theta d phi. So therefore the differential elements are given by dr ar, because the displacement in r direction is dr, this is b, and displacement in theta direction is r d theta, and displacement in phi direction is r sin theta into d phi. The volume of this element is given by, this is dr, and then this side is r d theta, and this side is r sin theta d phi. So therefore the volume element is given by r square sin theta dr d theta d phi. And the differential surface ds1 as shown in this figure is given by this magnitude of this area is, because this side is r d theta and this side is r sin theta d phi, is given by r square sin theta d theta and d phi, and it is pointing in ar direction.